Hi everyone. This is a code demonstration or code walkthrough for the project, like for the audio and text data depression classification using deep learning. So the dataset that I have used is from the DIQUOS database. So you can request access to the database through this URL. And for this particular research project, I have used the dataset, but which is quite large, so I can't able to upload it into the Moodle page. So I have given a link, SharePoint link here to download the dataset. So I have processed like the transcript and the audio file and used it in the deep learning to provide with the classification. So like this particular part of the code explains about like the process the transcript file for the classification. So the dataset is divided into train and test based on the file that is already present for the challenge that is given. So these are the participant IDs present and like the PHQ8 binary. So this is like the classification between like whether it's a depressed or a non-depressed class between the dataset. And like the transcript file that each participant has generated is like the conversation between the Ellie, like who is like a virtual interviewer, and like the participant. So I'll be focusing more on like the participant data to, how to say, understand the tone of the words that they have used to make the prediction whether like based on the sentence like whether they are depressed or non-depressed. So I will be walking through the code now. So I'm loading the libraries required for the EDA process, and like I have loaded the two files, the dev and test files, to read it. And I have loaded it into the, like here, like I'm removing the LE part, like where the speaker LE is not required for this particular analysis. So only the participants conversation is being stored here. So in this, how to say, the array, you could see the participant and the conversation and like the score and the binary score and the gender is present here. Moving forward, like I did some preliminary EDA for this. So you could see this is how the PHQ8 score is splitted. So until 10, like it is categorized as like they are non-depressed, and anything that is above 10, like they are categorized as depressed state. So moving further, this is the split of percentage of the classes, like out of the 142 participants, like close to like 70% of the data is non-depressed and only like 30% are depressed. So this is kind of an unbalanced data set. And moving further, and like this particular cell, like it talks about like the number of words uttered by the person like who is conversing to the interviewer. It's more or less similar, like it's the normal EDA. This is end of the EDA part. Going forward, like here, like I'll be doing the feature extraction and pre-processing steps needs to be done on the transcript files. So what I did is like I have loaded the files back to the train and the validation data frame, and so here I have how to say, like I've run through all the individual CSV files to read only the participants information, and like these are the train data frame, and for the conversation that they had, and like all the other parameters from the training file. Similarly, like this is the validation data frame that is generated. Moving further, like I'm loading all the pre-processing. For the pre-processing, like these are the dependent modules that are required, and I'm, how to say, like changing it to the NumPy array so that like I could do some further processing for the dataset. So here, I have changing the case of the words to a lowercase word, and moving further, like these are all the custom modification words that I have been used in the conversation. So like I'm just replacing it with these values, and like I'm just checking before proceeding further. And there is a regex function to ignore the case, like everything, ignoring the case here, and removing remove of punctuations, any comma or full stop is removed from the data frame. And like here, I'm using the natural language toolkit to remove remove the stop words present in the dataset. Here, like I'm just checking the count of each individual words that is present in each record in the data frame. So if you could see, these are the frequently uttered words. So I'm looking for the most frequently used words, like the common words that are uttered. So And the most common words is like from the reverse order is like these are the sparingly used words. So the most frequently used words is like and so like I'll be removing these common words from the data set further, and like even the most rare words has been removed as part of this particular cell. And like so here like it's just like a summary of the data frame, like total number of words in like 6 in the training data set and in the validation data set. Proceeding further, like I'm using a spaCy to what to say, like for the lemmatization process, like it's the use of converting the word to its root form. So here, like I'm converting the data set, like the new data frame, and like this is like for the, creating a synonym part of the data, like where like I'm converting it into like the token, the lemmatized words, and like here I'm getting the synonyms of each of the words, and like I'm replacing the existing data with the synonym word, and like these are concatenated here, and like leading to a final data frame, like which contains like 214 records, like each 107 for the data sets that I have, which have one like actual data and like the words that are synonymized here. So this is used for the this is used in the training of the model. So here I'm converting it into token, and like the padding of the data set is happened here, and like further like I used like the global vector representation like to retrain the model for this particular feature extractions. So once the embedding matrix is generated, a summary of the result is printed here. So here like we are splitting the data set like into the inputs and the target layer, like the dependent and the independent variables. So I'm just checking the variables that are splitted here. And like here, like we'll proceed to the deep learning model of the dataset. So I'm using a bidirectional gated recurrent unit, like with 128 filters and like with the ReLU activation function. And later, what is it like for the then the dense layer, like it has a sigma activation function with it, and like the optimizer uses a learning rate of 0.004. So I'll be running this for now. Training is completed. So after the 5-fold cross validation, the model with the highest accuracy has been chosen for the validation of the model. So the average accuracy of all the 5-fold is like around 82%, and like this is the best model that we have obtained. And like this is the confusion matrix and like the classification report. Here you could see like it has a 60% accuracy to classify the depressed and non-depressed class. Moving forward, like this is the ROC curve for the particular model, and like the area under the curve is comes around like 0.68. And like this is the code for the implementation of the bidirectional LSTM model, and it has a 5-fold cross validation, and I will be running this code now. The LSTM model is built now, and like the first model with the accuracy of 81.39 has been chosen for the and this is the ROC curve for the particular model. Like the ROC area to the curve is comes around like 0.61, and this is a plot for the accuracy and the loss for the all the epochs for the particular model. So moving forward, like this is part of the audio analysis. I'm loading the libraries for the model, and like here, like this particular cell removes the silence from the particular audio file and concatenate the segments and save it in the WAV file. I'm running this particular part. So the new files are processed now for the test data. Similarly, like I'm going to run for the test data set. So now like both train and test audio files have been processed and all the silence have been removed from the data. If you could see like in the interim folder, like all the files have been created. So it has like the file ends with a suffix no silence. So from here, like we will be extracting the features from this particular data. So I'm loading the libraries required. And like here I did some EDA for the audio file. So like see like what is the spectrogram it would be like for the depressed class. like like for the non-depressed, like this is the wave format that has been generated for the MEL spectrogram. Similarly, like for the depressed scenario, like this is the output, and like there is one another EDA like that I did for the MEL spectrogram. Okay, like these three are the functions to generate the features for the or to say like for the deep learning model to classify the depressive case. And like here, like I'll be processing each file and I'll be extracting the features from the file. So I'll be running this code now. So all the three features have been extracted here from the train dataset. Similarly, I'm going to extract for the test dataset. So all the three features have been extracted for the test dataset and is stored in the CSV file. Here I'm just checking the features that have been extracted on the variables, features df test, the data frame. So here, like it is the implementation of the CNN model. This is a basic CNN model to try the classification for the audio dataset. Classifies. So it has an accuracy of 0.54. So I have implemented another model with a hyperparameter tuning to see like is there any better model with a better configuration for the hyperparameters for this particular CNN. The model is trained, and like here I'm just predicting the response from the model. And it's like to concatenate the audio and the text modality. So I have used the meta learner, like I have tried with the logistic regression and the gradient boosting to see like with combination of the model to have a better classification. So here, like from the prediction, like it tries to calculate the overall classification between the depressed and the non-depressed class. Similarly, like I have used for the GRU model and the CNN model. It is like the LSTM and the hyperparameter tuned CNN model. Overall, like I tried to combine like the transcript and the audio file to find a final prediction, and like with what to say, like with the positive depressed cases, like that is the focus of this particular research project. Thank you.